You're listening to WMPG 90.9 for Portland, Southern Maine Community Radio from USM. Live from the Orion Cygnus arm of the Milky Way galaxy, this is Scientifically Speaking, a weekly half-hour program devoted to elegant curiosities, and I am one of your hosts, Sarah Ching, and joining me as always is Bernie Ryan, DJ Star Watcher. How are you, Bernie?
Yes, hi Sarah, very good, thank you.
Bernie's our professor of the Astronomy Lab here at USM and our local protector of the night skies. Reach out to us at WMPG Scientifically Speaking at gmail.com or on Twitter at WMPG SciSpeak, and you can head over to WMPG.org to find the last 5 weeks of archives of all of your favorite shows, including this one. Bernie, could you let our listeners know what is up in the night sky for this coming week?
Yes, certainly. So this will be Friday, February 18th. It'll be a waning gibbous moon. The moon was full on the 16th, so just a couple days ago. That was a famous snow or hunger moon for February. So that was a full moon. So the moon comes up about 50 minutes later every night. So it'll be up like a little less than 2 hours later as a waning gibbous. Days are getting longer. We only have about a month to go to spring. So sun now rises at 6:42 and sets at 5:28. So the evening part is nice especially. Planets pretty much the same. Jupiter's getting a little bit lower. We're not going to lose it till like next month, but it's still in the evening sky setting around 6 or 6:30. And then if you like to get up early, you can see Mercury, Venus, and Saturn in the morning sky. And eventually, now I should mention this now, but I can mention it again later, of course, when it happens. When we lose Jupiter in a month or so, it'll turn into a morning planet. That won't happen till like June. But at that point, we'll have all 5 bright planets lined up in the morning sky in sequence, starting with Mercury, going out to Saturn. That's very unusual. So it's not too early to start getting ready for that. You might want to photograph it, certainly look at it, and it'll be about 45 minutes before sunrise starting in June. So I'll give you that now. Yeah.
Awesome. Thanks, Bernie.
You're welcome.
I am enjoying the longer days.
Yes,
for
definitely.
Sure. All right, and if you couldn't take notes fast enough, you can also check out the monthly What's Up column in the Portland Press Herald, written by yours truly. So, today's show, welcome to a new episode of Scientifically Speaking. Every once in a while, someone in my circle will say, "Hey, Sarah, I have a science question." And I'm like, I don't know everything, but I have enough foundational knowledge, I think, that I can generally logic my way through a semi-answer. Or what usually happens is it makes me come up with even more questions, and I've now found myself down a rabbit hole. Or sometimes I'm like, I don't like that question, I don't care, and I don't do anything. But recently I was asked, hey, how exactly are fossil fuels made, or were they made? And I fumbled my way through it with something like blah blah organic matter, blah blah compression, blah blah millions of years, and then crude oil lakes. But I didn't actually know anything beyond that. So there is a little bit more. Bernie, what is the one myth that we want to dispel today?
Yes, so a lot of people seem to think that fossil fuels are made of dead dinosaurs. So if there weren't enough dinosaurs in biomass, of course, to create all the fossil fuels that we have, the timing was similar. I mean, the last dinosaur died out 65 million years ago, and the first one showed up after the Permian extinction 250 million years ago. So they were actually here relatively short, and that's a lot of the fossil fuel we use is compressed sediment from that time period. But a tiny, tiny bit of it would be a dinosaur unless they happen to die in some coal or what turned into oil or coal or gas. They really would not be dinosaurs. So that's a good myth to dispel.
Yeah. That was a very professorial answer.
Mm-hmm. Well, I
really
had to throw in the Permian extinction and all those things. That was just kind of neat. We're in the process of the 6th major extinction right now. About 100
right?
years ago, people didn't even know that something like an extinction was even possible.
Yeah.
So that's pretty interesting stuff. But that's a whole nother show, obviously.
It's a whole nother show.
Yeah.
So as Bernie mentioned, I think fossil fuels have been, you can kind of call it, they've been in the making for over like 300 million years. Dinosaurs really only came into the picture about 230 million years ago. And like Bernie said, if you were just walking around on land and you had died as a dinosaur, you're less likely to become, you're probably not going to have become fossil fuels. You are going to be a fossil that an archaeologist has dug up. And so it's probably unlikely that most land dinosaurs that we think of when we think of dinosaurs are actually the gasoline that is powering your vehicle. Speaking of which, I do see a lot of like stickers on people's cars that say something like "powered by the dinosaurs" or
Oh
something
yeah,
like that.
I've seen that too.
Um, but we are dispelling that myth today.
Yeah.
And so, as Bernie said, as plants and animals, mostly actually fish or marine animals, as they had died, they would collect at the bottom of swamps. That's one way. They would collect at the bottom of swamps and buried by dirt over many, many years. And this burial compresses that organic matter with kind of decomposing bacteria. And then this packed organic matter turns into coal, which is one form of fossil fuel. And so combine all of that with really high temperatures, high heat, high pressure, all of this organic matter then turns into coal. And if you don't know, what's interesting is that, nowadays the term organic is used a lot to kind of refer to as like natural things. And technically, in chemistry, organic matter, organics actually refer to anything that is carbon based, so some kind of a hydrocarbon backbone. And so all of this organic matter, gasoline, fuel, coal, they're all organics. And coal is also is made of all carbon. So that's one type of fossil fuel. There are two others. And before I get to those, though, just back to coal a little bit. Coal it's those like shiny black rocks that you get if you are a bad kid
Yeah.
at the end of the year on Christmas.
Yeah.
And somehow Santa Claus is carrying around a whole bunch of coal for all the naughty kids. But when it's burned, it makes heat and light energy. And there's actually evidence that early humans used coal for heating and cooking, like just a long time, like cavemen type humans. And it burns longer than wood, and so you don't need to harvest as much and as frequently as you would
That's
have
right.
if you were harvesting
With
wood.
wood.
And then in the 1800s, around the time of the Industrial Revolution, that is when we started to use coal for heating homes and eventually to make things. And as we all know, coal needs to be dug for, and it's so we're here to kind of try to convince you. I mean, I'm sure all of you already know, but our goal is to convince you of how bad these things are. And one of the things with coal is that it causes extreme environmental degradation. And we know that because we have to blast off or through or into mountains. Sometimes entire tops of mountains are gone because we're trying to basically open a canister of coal. And the deep earth caves created are actually also very toxic for humans. So coal can actually be mined in 25 of our 50 states here in the U.S. and is right now currently primarily used to generate electricity. So take note that when you drive an electric car, you're probably still burning fossil fuels, kind of secondarily, because
But
you're
less of
using.
them, yeah. It's still
Yeah.
more efficient than a regular car.
Yes.
Yeah.
Okay. Petroleum, that's kind of the second type, and that breaks down into crude oil and natural gas. And these types of fossil fuels were actually made from ancient seas. And so plankton, essentially, that died, they sank to the bottom of the oceans. Debris then settles through the water, covers the dead plankton. Again, we have microbes, bacteria that eat or decompose those dead plankton amongst a myriad of chemical reactions. And this process, over many, many millions of years, forms a waxy substance chemical called kerogen, and also a black tar called bitumen. And primarily, we're looking at this kerogen, which, very similar to coal, is compressed and buried deeper and deeper And again, heat and pressure transforms it into hydrocarbons for crude oil. Adding more heat and more pressure, we get small hydrocarbons for natural gas. So you've got those two end products that come from ocean plankton, basically. And eventually, because both the oil and gas are less dense than rock and water, they can actually seep upwards through the porous earth and can form a reservoir either above ground, such as the lakes in the Middle East. You can actually see these black oil lakes in the Middle East, or reservoirs under kind of a non-permeable rock, like at some kind of geologic fault where it can't kind of go through. And so this is where drilling and fracking, etc., all come into tap into that energy source. And speaking of kind of the density of oil, I think, Barney, you have actually been down to Florida to
Hmm.
see like some of those oil spills, and
Yeah.
there was something about that that surprised you.
Yeah, it was a little different. See, I just expected maybe some kind of a sheen or just something like floating you would see when, a little gas or something spills out of a boat. No, these were clumps of oil, maybe about a half a foot across,
Mm.
and they were like maybe every 5 or 10 feet apart. And they were really bad. They were washed up on the beach. I didn't actually see any, birds completely covered in the stuff because this was from a spill that happened a while ago. Nothing
Mm.
like the one in the Gulf. So I was
Yeah.
just surprised. And I mean, it didn't smell good and it looked really bad. And there were these clumps of oil. I guess something based on the chemistry, it clumps together. And then it probably took months and months. And this was like month after anything spilled. This was like Palm Beach, Miami area, part of Florida, maybe like 30 years ago.
Oh wow.
It's pretty
Oh
bad.
wow.
Yeah, it was a long
So
time.
that's far from where I would have
Yeah. So
expected that, but
maybe something happened in the Gulf. I don't know how it
yeah.
got around to the ocean side.
Hmm. Hmm.
But
Hmm.
again, before the big spill in the Gulf, that was just about 10 or 11 years ago. It was way before that.
Sure.
I was kind of surprised. It looked really bad.
Yeah.
Yeah.
So one of our most famous scientists here in Maine, our local resident historical biologist Rachel Carson, actually kind of has some. I mean, she studied these tidal pools, and I know we talked about plankton in terms of that being the source of all of our crude oil and natural gas today, but she had something to say about this process.
Yeah. So I'll read you a little bit from her. Actually, I have a book called The Lost Woods, which is like a compilation of some other ones. But I think this book came from the sea around us. She had written
Mm.
like 4 books. So this just gives you a really interesting way of seeing plankton. I mean, basically the zooplankton, which are little single-celled animals, and then most of the productivity of the oceans is actually phytoplankton. As much as
Mm.
50% of it comes from phytoplankton. And this is what compresses over millions of years, like Sarah said. Okay, so here goes. The ocean is a place of paradoxes. It is home of the great white shark, a 2,000-pound killer of the seas, and of the 100-foot blue whale, the largest animal that ever lived. It is also the home of living things so small that your 2 hands might scoop up as many of them as there are stars in the Milky Way. And it is because of the flowering of astronomical numbers of these diminutive plants, known as diatoms, that the surface waters of the ocean are in reality boundless pastures. Every marine animal, from the smallest to the sharks and whales, is ultimately dependent for its food upon these microscopic entities of the vegetable life of the ocean. Within their fragile walls, the sea performs a vital alchemy that utilizes the sterile chemical elements dissolved in the water and welds them with a torch of sunlight into the stuff of life. Only through this little understood synthesis of proteins, fats, and carbohydrates by myriad plant producers is the mineral wealth of the sea made available to the animal consumers that browse as they float with the currents. Drifting endlessly, midway between the sea of air above and the depths of the abyss below, these strange creatures and the marine inflorescence that sustains them are called plankton, the wanderers.
Wow.
And now you have a much better sense of what plankton are. And the word planet means wonder. So plankton is the wonder of the seas, and the planets that we see, I always talk about, they're the wonders of the skies. And this is something she didn't even connect, but that is just such a poetic way to show how it sustains all the life. And this is what dies over millions of years and becomes oil, of course. But right now it's living, it's huge, it's sustaining life right now.
Right.
Yeah.
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 I mean, that does give it a
Hmm.
really poignant kind of sense of
Yeah.
the importance of
Yeah.
these tiny little I mean, you can't even see them. At least
Yeah.
we
They're
can't.
microscopic, literally,
Yeah.
way less than a micron.
Mm-hmm.
In two hands, you can scoop more than 300 billion, and that's how many stars there are in a galaxy.
Mm.
300 billion of these little tiny phytoplankton,
Wow.
living little diatoms with the neatest geometric shapes. I mean, if you ever watch a video on these, they literally have thousands of different shapes and
Yeah.
species. They're just amazing, and you
Yeah.
can't even see them without a
Yeah.
microscope.
Yeah. Right. Right.
Yeah, yeah,
Beautiful. Well, thank
yeah.
you for sharing that. And
Oh,
that
you're
was
welcome. I
from
just was reading
her.
that. I had to share that because that's a great
Yeah.
paragraph.
And so that was from her book, The Sea Around Us.
Yeah, and then there's
Mhm.
some other things summarized in this book that I got it from. She wrote obviously A Silent Spring, and then they discovered a couple other books, some woods. She lived in Maine for a while, and she wrote something called The Lost Woods up mid-coast Maine. I don't know exactly where she was, but I'd recommend you read what she's written for all kinds of the poetic nature and the scientific nature. She was a writer and a biologist,
Yeah.
so yeah.
I've been wanting to go to her preserve in Wells, but I haven't
Mhm.
been able to make it out there. Primarily
Oh yeah,
because
I go
no,
there all the
yeah,
time. There's a 1 mile nature trail there, and I
yeah,
was just
yeah.
there actually just a few months ago last fall. It's a little
Okay, I'll,
boardwalk. It has little
yeah,
stations, and it has a nice view of the little river and then the ocean. And I always see some interesting creatures when I go there.
we'll have to check that out.
Yeah, you should.
Cool. So I
Hmm.
think what we have learned so far is that most fossil fuels are unlikely to be dinosaurs. If they are, they are more likely to be marine dinosaurs. And then most fossil fuels are made from plankton, from plants, and other kind of marine life. So that's your takeaway for today. But no, no, we do have more. So going back to how much we are trying to convince you to consider alternative forms of energy within the next few years within your means. So, as of 2016, there were 1.65 trillion barrels of proven oil reserves. And proven just means like we know that they exist. There might obviously be more. Hopefully, we don't discover more because, you know, these fossil fuels are non renewable for a reason. Technically, over the span of millions of years, they could be considered renewable, but in our lifetime, they are not because they take millions of years to create. And so, by using these fossil fuels, we are releasing all this sequestered carbon dioxide from millions of years. I mean, this is ancient carbon dioxide, if you will. And so 1.65 trillion barrels of proven oil reserves. That is equivalent at the time to 46.6 times our annual consumption as of 2016, which estimated 47 years of oil left. So I think that that number varies depending on what source you look at. I have seen sources more recently that suggest we have about 50 years. So I think it's reasonable to assume that we have less than 50 years of our proven oil reserves left to consume if we are going at the rate that we kind of continue to go at. And in 2016, just to give you a little bit of an idea, we consumed over 32 billion barrels a year, or almost 100 million a day. Venezuela, Saudi Arabia, Canada, Iran, Iraq, Kuwait, the United Arab Emirates, Russia, Libya, and Nigeria are the top 10 countries with the most oil reserves, with the first three comprising of almost 45%. The US is actually 11th on that list, so we're not too far off. I do wonder how much of that is like, I don't know what we own, quote unquote, in the Gulf, because I know that's a big source, and then obviously Alaska is a big source as well, and then we've got fracking and all those other terrible ways of releasing fossil fuels from the earth. But Maine gets 3/4 of our electricity from coal, natural gas, fossil fuels, and nuclear energy. And that's from the Natural Resources Council of Maine. So gas prices are up. You can blame that on anyone, but in reality, we should probably be focusing our attention on solutions rather than what is attacking our existing way of life as we know it. And I know it's hard. It sucks because we don't have money for solar panels. We don't have money for a Tesla car. We don't have money for a lot of these things. We've seen disasters from nuclear, power plants, but we've also seen disasters from oil spills. So which ones are, what are the best alternatives? And again, it's not just electricity that we need to get away from. Some people don't even realize that, or they forget that petroleum isn't just something that lets us go places or turn on our lights or charge our phones. It is actually in our clothing. It is in the food that we eat. It is, the plastics are that, we are using everywhere is all fossil fuels. That's how we make it. And Bernie is
Yes.
going to scare you
Yeah.
from microplastics.
Yeah. I mean, the plastic's the whole problem. I'm sure you've heard they're not biodegradable, and they're not.
Mm.
And they're not, which even worse, they're not really even recyclable. I mean, they
Mm.
make it look like you can recycle, but way less than 10% of it ever gets recycled. You may be very diligent and put out like half your trash, like in my case, way more than half my trash is recyclable stuff when I bring it to my transfer station, but I have no idea if they ever recycle it. The prices are bad. China isn't taking it anymore, and so on. So it's that's another issue. But yeah, so what happens to plastic physically? It just gets smaller and smaller. There's smaller and smaller pieces. Those are called microplastics. So it depends where you could take a sample. If you take it in Maine, you may not have huge numbers, but if you go to California, and there they range from maybe like a few hundred to many thousands per milliliter of water. I mean, I don't know the exact numbers, but there's so many in, and they are microscopic, just like this little plankton. But instead of feeding an ocean and sustaining it, it's kind of doing the opposite. We all have it in our water, even good spring water, I'm sure has it. It's in our lungs, probably not to the level that it would really, like ash from a volcano or something. But the microplastics are there; they don't go away. They just get smaller and smaller, and that's a big issue if we don't somehow clean them up or stop creating more of them and all the, or actually recycle instead of just think we're recycling. That would be another big step. But that's an
Yeah.
industry corporation thing they can do. Yeah, so that can be pretty frightening.
Yeah, I mean, and that's so hard because, like here in Portland, we have single stream recycling.
Mhm.
Um, and, one of the big no nos is throwing away plastic bags, so they
Yeah.
can't recycle them. But people will bag their quote unquote recyclables into plastic bags. And I don't know if any of that goes through. I think that all ends up in trash.
Most of it
And
does.
so even then, or maybe we don't prep our recyclables to be recycled enough. There's a lot of work that goes into that. um, I actually recently bought a bag of chips, and the only reason why I bought this bag of chips was because the bag said the bag was compostable. And I do have curbside composting, so I was like, oh great, I can just throw the whole thing in there, and it was super nice. But it reminds me of, do you remember the fiasco with Sun Chips many many years ago?
Not really. I remember something vaguely about that name, but what happened to them?
Yeah, so the Sun Chips, they, I believe, this is just from my memory, but this must have been like 10, 15 years ago.
Mhm.
They had created a compostable plastic bag,
Mhm.
but everybody complained, like the nation complained that this bag was too loud, like it was too crinkly. And when I opened this bag that I was just talking about, it was really loud. I mean, it didn't bother me, but it was like the material was just slightly different, and so it was like.
Yeah.
But that was like this whole backlash was this company was trying to do something good, I think, and the public was like, "Nah, it's too loud. We're not gonna have this packaging." And so then they went back to regular plastic.
Oh, that's
That's
true.
terrible.
Yeah, I mean, they're actually loud would be good because it might wake them up a little bit knowing that they shouldn't be using all this type.
Mm,
And if it is louder and knowing it's actually good for the environment, that would be great.
right,
I
right.
wouldn't try to make it less loud.
Yeah.
See, I think the loudness would be a good feature, but if
Yeah.
people don't like it, I guess they won't buy it.
I love it. I love that we're both supporting loud
Yeah, loud
compostable
chips
bags.
bags.
Exactly.
Okay. Yeah.
So
Mhm.
we want to talk about just a couple of alternatives. We've actually had a couple of shows in the past, and unfortunately, I don't have those recordings. But for example, previously we had Maine Standard Biofuels on our show back when we were doing the show at MPG. And Maine Standard Biofuels, again, I'm just kind of talking about the great work that they do. But they are a biorefinery that collects used cooking oil and recycles it into biodiesel. And in that show and in a couple of other renewable energy shows that we've had in the past, Bio 20 is kind of the most common form of biodiesel, and that's essentially 20% biodiesel and 80% petroleum diesel. And it is burned, it is used the same way that petroleum diesel is. You don't need a special tank or anything. And the difference is that because it is created or refined from plants that are grown, that as those plants, their life cycle, they are kind of sucking in CO2, which is equivalent. They've done those calculations, which is equivalent to the CO2 that is then released when you burn it again. And so net kind of carbon neutral is a goal there. And I believe in order to use 100% biodiesel, you do need special kind of engine. But when you add it to like the Bio 20 formula, when you have that, it actually makes the diesel overall run more clean. And so there's really no disadvantage to it.
Mhm.
And then the other one that we also had highlighted was this is not a consumer one necessarily, so you couldn't go out and for example, install or buy this. But Ocean Renewable Power Company, if you recall, we also had them on quite a while ago. But we had the president on here, and they have a headquarters here in Maine, and they are marine and river renewable energy technology company. And basically, what they do is they install these turbines at the bottom of riverbeds or at the on ocean floors, and they use tidal energy and convert that to energy that we can use for, powering our city life. And so, anyways, those were kind of two shows, two organizations here in Maine that we had highlighted in the past. And Bernie is actually our resident natural resource management. I know you've had a lot of experience with biofuels and biomass on the farms and stuff that you've lived on and worked
Yeah.
at.
Right. Well, there's other things, of course, that people can do. First, just like do an energy audit of your place and insulate it. That would be easier than because then you're not wasting the fuel in the first place that you're getting. And then maybe if you just do a few solar panels, maybe just for your heating,
Mm.
for the hot water versus the entire house. And then there's actually something that you can even use algae for solar panels. I just saw some of
Mm.
this. I didn't really look
Mm.
into it, but that's a whole different type of generating some of the heat with algae, which would be kind of neat. I don't know how
Interesting.
widespread that is or how people can get a hold of that yet. And then obviously just the LED lights. I mean, those are great. They don't put out any wasted heat energy. They only put out, you get the three colors. They combine it. That your eye thinks it's white. You can make any colors out of the way you combine LED lights. You measure them in lumens and not in watts because it's the light output and not the heat output, which is totally
Mm.
wasted. So there's lots of things you can do even on a small basis to be more efficient.
Excellent.
Yeah,
Awesome. Thanks for that,
mhm,
Bernie.
sure.
And hopefully, as a listener, you have been convinced that fossil fuels are terrible And realistically, we can't all make the switch, right now to like a solar panel car or whatever. That's probably very expensive. But hopefully you're thinking about this more, and there are resources out there. The Natural Resources Council of Maine is a really good one. Greater Portland Council of Governments is also a good one, and you can kind of learn more. And if you have the means, by all means, go renewable. You have been listening to Scientifically Speaking here on WMPG with myself and Barney. Stay tuned for Something for the Weekend with Anella, and from your favorite nerds, just a reminder to vaccinate, to mitigate, and then we can all congregate.